Okay. So a pointer can point to anything, right? I've told you that hopefully tons of times, or at least, yeah. So a pointer can point to a function.
Yes.
All right, good. So if you want to write a function and have that function applied to every member of the data of your binary tree, you would just have to do a traversal being passed a function as well. Specifically, this, I believe this is in your lab. Let me go look at it real quick. In order to traversal, passing in some visit function. So the question is, how do we write that function? Well, all right. Well, let's see. We'll go ahead and go up here, and I'll make a little function. I'll call it void print, passing in, I don't know, t at val, or I should say int at val. And we'll just have it print out. Not necessarily. Not in this case, because if I'm going to template it on integers, then I just have to make sure that this print function is passed in an integer. And I'll change the function from print to just myPrint. And I'll just have it print out val with a pipe afterwards, just for funsies. So if I were to write another function, wow, that was terrible. Yeah, this really needs to be broken up. Test function pointer, and it's going to be passed a, and I always forget the syntax for this. Here we go. It'll be passed a void at visit. That's also passed an item at val. So we're inside this test function pointer. Let me see if I actually typed that correctly. Looks like I did. Then what I can do is I can go star visit, passing in the function 100. Make sure I typed that correctly. Nope, I did not. No. Oh, because it has to be a value. Hold on. 100. Wow. Yeah. There we go. Test function pointer. What?
No. You passed in a val.
Why did it have a problem with that?
Oh wait.
You could just pass in val that you.
Oh, hold on. Let me change this again.
Oh boy. Something. Sure.
All right. Good. So test function pointer. All right. So that's blah blah blah. Lots of code. I'm gonna leave that up there. And I can do test function pointer at my function, or my print, I'm sorry. So let's see if it actually works. It did! See, there's the 100 and then the pipe symbol.
Wow.
So what am I doing here? Well, my print is a function right here. That's the wrong thing. There we go, function right here. Let's jump down here. I should probably put these two things together, shouldn't I?
Yeah.
So I have my function I wrote right here. This function takes a pointer to another function that must return a void and be passed an integer reference. Well, my print returns a void and is passed a reference to an integer, and then just prints it out. And notice that what this does is sets a value to 100 and then calls visit with that val.
Why would you do this?
Why would I do this? What if you want your binary tree to be able to take any function and apply that function to all its member data, member variables, or member data. So if you can pass a function to a binary tree, like print, and you say in order traversal, then it would go do. All right, print. Let me call that function on the 18. Call the function on the 20. Call the function on the 60. Call the function on the 68. Call the function on the 70. Call the function on the 90. Call the function on the 98. That way, the user of your binary tree, you can just pass them a function pointer to just do some action on every element inside the binary tree.
Okay.
So if you want to sum it, you could pass a sum function. You wanted to find the product of everything, you do that. It's just something to evaluate every element. All right. So hopefully you can see this part can be a little confusing, but notice that once it's passed a function pointer, to call it, you first have to dereference the function pointer variable. Notice that I called it visit. I could have called it v2. And then down here, I would just have to call it v2. And there we go. So the variable name that's being passed is right here.
So the something is
The something's actually irrelevant
okay.
because it's just being passed an integer reference
Yes.
of some sort. But all it's saying is that this is a pointer to a function that returns a void, like this guy up here, and is being passed an integer reference, like up here. I'm going to create a value of 100 and then dereference the pointer so I can call it passing in val, which is this guy up here.
So what if you actually wanted to like print this stuff? Since you have val equal to 100, wouldn't that cancel that out?
Well, the point here is for your lab. Oops, that was bad. In-order traversal with the visit function does an in-order traversal of the binary tree calling visit on each node.
Why does that one have const?
Oh, so it does not manipulate the binary tree. Look at all this const. This probably just give you headaches, something.
Yeah.
Yeah, well, that's how C++ is.
It's just one
It's
more
like-
headache.
It's like that one day we were doing it and you were like, I'm just gonna get rid of the private and everything worked.
I'm done with
You're like,
this.
screw this.
Alright, does an in-order traversal of the binary search tree calling visit on each node. So you're passing a function to a traversal function of the binary tree, so they'll call your function that you're passing in on every node.
Yes.
Alright? Yes.
I'm so confused about the 100.
I've just given you an example. Obviously, inside of your binary tree, it's what's ever stored in there. It could have been 55, and then when I do it,
How would you like? Because you had to make that number in order to use.
right? I mean, it could be something like m node dash m data, right there if you were inside your binary tree.
Oh, so you would.
And then you
leave
would do
that.
it recursively?
Well, you're doing an in-order traversal, so you
Oh, okay.
want to do it recursively, yes.
Oh, I get yours.
Okay. Maybe. I think I got it.
Let's see. That's terrible. There it is. Good. Phew. That's all they tell you.
Great.
that's the extent of their knowledge.
All right.
Apparently they don't know.
They didn't know how to make a
trees,
binary
so-
tree though. So
This is great. Okay. So when function pointers cause you headaches, sorry, just come and talk to me. But hopefully review this slide real quick. And now let's go into the summary. That's not really a summary, and more of just a full explanation of everything we just talked about.
We need to summarize this stuff?
Yeah.
Why haven't we done that yet?
Yes. By the way, there is an error in the delete function. If y'all ever catch it, there
Our
is.
delete function?
The one we wrote today. Yeah.
What?
Yeah.
what?
Oh.
Go back.
Faulty code.
Oh yeah. It's wrong. It wrong. It wrong.
So wait, have you been giving us
It
faulty
is
code
definitely
this whole
wrong.
time?
It is
Yes,
wrong.
He will.
Oh, I do that all the time.
Yeah,
But it
he's
worked.
been doing it the whole time, especially with the first project.
Yeah.
He
All
made
the
faulty
code.
code on purpose.
All the code is.
See if you catch it.
It is always wrong.
Now, I understand why too.
Okay.
It is always wrong. All right. Binary tree is either empty or has a special node called the root node. All right. Great. The node of a tree has two links to it. Okay. A node in a binary tree is called a leaf. It has no left or right children. aka it's childless. Node U is called the parent of node V. Is there a branch from U to V? So 60 is a parent of 20. The height of binary tree is the number of nodes and longest path from the root to the leaf. 1, 2, 3, 4. Okay. Inner traversal. I hope we've done that enough.
Yeah.
Good, that's it.
Thank God.
Any
Lab time?
any question before I talk about the lab?
Oh yeah, let's not talk about that.
Yeah, we still have a lab. We're always going to have a lab.
We always have lab.
All right, lab. Oop, hold on.